Welcome to your next independent study video. This is going to be page 29 in your notebook. And just wanted you to know that this set of notes is only going to be on your chapter 6 test. So it's not going to be on the quiz, it will be on the test instead. So 6.7 is all about variation, about how two or more variables relate to each other. There's three main kinds that we're going to talk about. The first one is direct variation, and it takes the form of y equals kx. So x and y are your two variables, and k is something called your constant of variation. It is just going to be a number. It's going to be a constant. The problems, once we get into question number 6, will have you solve to find k as part of the problem. If two variables x and y vary inversely, then instead of k times x, we're going to have k divided by x. And then the last one is if you have two or more, and that's going to be joint variation. So two or more variables is going to be joint variation. So some of the terminology for each of those formulas: y varies directly as x. Y is directly proportional to x. Both of those are fancy ways to say y equals k times x. Y varies inversely as x, or y is inversely proportional to x. That's when you put the x in the denominator. And the last one, z varies jointly as x and the square of y. So z varies jointly, telling me I'm going to have at least two more variables, as x and the square of y. So we have 8 problems we're going to go through. The first 5 are just going to be getting used to this terminology, and then we'll actually do some calculations in examples 6, 7, and 8. For each variation, give an equation that relates the two variables. The circumference c of a circle varies directly as the radius. So c varies directly as r. C varies directly as r. So again, I'm looking at that first equation for direct variation. Number 2, the area A of a circle varies directly as the square of the radius. So the area varies directly as the square of the radius this time. Number 3, the area A of a square is directly proportional to the square of the length of a side. So again, we're doing direct. A is directly proportional to the square of the length of the side. In example number 4, I'm having you essentially work backwards. I'm now giving you the equation. You're going to tell me the problem or the terminology. So in number 4, I have P is equal to KS times T. So the moment I realize that I have two variables on that right-hand side, I'm going to need that joint variation. So P varies jointly as S and T. Number 5 has a fraction, so I know I'm going to use that inverse terminology. H varies inversely as the square of T. Okay. So nothing too crazy, that's just to kind of get you used to this terminology. How we're going to apply those formulas is what's going to happen in 6, 7, and 8. So in question number 6, it says y varies directly as x. So just from that first part, I know my equation based on examples 1 through 5 is going to be y equals kx. The next piece of information they tell me is going to help me find k. When y is 15, x is 24. So I'm going to plug in those two values and solve for k. So if I divide by 24, and then I simplify, and then I divide by 3. K is just 5/8. So really my equation is y equals 5/8 x. This question wants us to go one step further and wants us to find x when y is 25. So now that I have k, I can plug in 25 for y and solve for x. Multiply by the reciprocal. And I get x equals 8. Oops. I was wondering what happened there. That should be a 5. Let's try that again. Multiply by the reciprocal, 5/8. Left side cancels except for the x. On the right side, I can take out a 5, leaving me with 40. That makes more sense. For question number 7, we're going to approach it the same way. The period of a pendulum is directly proportional to the square root of the length of the pendulum. So the period is directly proportional to the square root of the length. The period is directly proportional to the square root of the length. So that's the part that's telling me my original equation. The next piece, knowing that the pendulum is 64 centimeters long with a period of 1.6 seconds, is what's going to help me find k. So the length is 64 and the period is 1.6. So if I solve, I get k equals 0.2. So really my equation is the period is equal to 0.2 times the square root of the length. The last question, or the last part of the question, is telling me to find the period when the length is 100 centimeters. So I'm going to put in 100 in for L, my length. So it's going to do a complete cycle in 2 seconds. And then the last one, number 8. Remember, the first part's going to tell me my equation. The surface area of a cylinder varies jointly as the radius and the sum of the radius and the height. So surface area varies jointly as the radius and the sum of the radius and height. I always like to use the letters that make sense for the problem, so I don't have to go back and remember what was what. Remember, the next piece of information is going to tell you your K. So my height is 8. My radius is 4. And my surface area is 96 pi. That's 12, and 4 is, 48. So if I divide by 48, k is going to be 2 pi. So my equation is now, when I plug 2 pi in for k, my surface area is equal to 2 pi r times the quantity of r plus h. The last piece of information they're going to ask for is, in this case, find the surface area of the cylinder if the radius is 3 and the height is 10. So radius is 3, height is 10. So I have 6 pi times 13, or 78 pi, and if I'm going surface area, that's going to be centimeters squared. So if you need a little extra practice with that terminology, there is a blank worksheet and one with my solutions if you want to look through any of those, again, before your Chapter 6 test. This concept is not on your quiz, it is on your Chapter 6 test.